So we'll talk about different types of quadrilaterals, right, and their properties that would help you to solve the problems. So first of that kind is parallelogram. First of what are quadrilaterals? So just brief discussion on that. A four-sided closed figure, right? Like how a three-sided closed figure is called a triangle, four-sided closed figure is called a quadrilateral. In that we have types like parallelogram, square, rhombus, rectangle, trapezium, and lot many, but we will talk about the major varieties that generally are tested in different exams. So parallelogram, right? What is the requirement for something, a quadrilateral, to be called a parallelogram? Opposite sides are parallel, right, and opposite sides are equal. Then it has to be a parallelogram. Even one of them, if I know is true, automatically the other is true, and hence it is a parallelogram. Right? I'll write it like this shortly: parallelogram. Right? If I know a pair of opposite sides are constructed like this by parallel lines, so then this must be a parallelogram. And the opposite sides will be equal. There is no way that it will not be equal in this way. So if I know that I have used a pair of opposite sides which are parallel to construct a closed figure, that is a parallelogram, and the opposite sides would be equal. Or if I know that the opposite sides of a closed figure are equal, then they will be parallel and it is a parallelogram. Right? This is the very core point that will define a parallelogram. In parallelogram, we also see that opposite angles are equal. That is, this and this are equal, and angle A and angle C are equal. Right? So opposite angles are equal. Opposite angles are equal. And the sum of adjacent angles will be 180. That is, angle A plus angle D is equals to 180. Angle A plus angle B is also 180. Right? This plus this, or this plus this, or D plus C, or C plus B. Right? Any two adjacent angles I pick, the sum will be 180. Right? And as you know, all the four angles will sum up to 360 degrees, right? Closed figure, quadrilateral, triangle is 180 degrees and a quadrilateral is a 360 degrees. So opposite angles are equal and the adjacent angles sum up to 180. That's another important factor or property of a parallelogram. Then we need to know area, we need to know perimeter, on something on the diagonal. Okay, these are the standard things that we get to see in all the shapes that we'll discuss, all types of quadrilaterals we'll talk about. So just to pay attention to these things. First, area. So standard formula is base into height. Right, how the area of a triangle is half into base into height. So here it is base into height, and base is not always AB. It could be any one of those four sides. If I take AB as my base, then I need to find the height drawn to the base AB from the other two vertices, from any one of the vertices basically. From D, if I draw a perpendicular line, it will be like this. This will be the height. If I draw from C, it will go on the exterior side. Right, so I need to extend it like this. Right, and this will also be H. This is H. This also has to be H. Right. So what is the area in this case? It will be AB into H. Right, we would not count this length. Though it looks like we are extending this side to the base to meet the height, does not mean I'll take the base as the entire line. No, it's only AB. So AB into height H is the base into height. If I take AD as my base, then from C, if I draw perpendicular, B, if I draw perpendicular, it will go like this. Right, from B the perpendicular will look like this, from C the perpendicular again will look on the exterior side, so I need to extend this to get this. This will be height H2, and then I could also do AD into H2. Right, so be careful, height is the perpendicular drawn to any one of the sides of parallelogram, and that side of a parallelogram is counted as the base, and into height is what I need to do. I need to just maintain a perfect pair of base and height. I cannot use height H of this and base AD. Right? If I use base AD, then height has to be perpendicular line drawn to that side of the parallelogram, that is H2 here as shown me. Right? So that's the formula for that. There is one more formula, that is product of two adjacent sides into sine of angle between those sides, those two sides. So as you know, right, generally we denote it like this: A, B and B. Opposite sides are equal, so let me use A and B and B. So what will be this? If I multiply any two adjacent sides, AB, BA, AB, it's all the same. Sine of angle between, right? Let's say sine A. I use sine A, sine B, sine C, sine D. It's going to be same. Why? Because sine A and sine C are anyway equal, because A and C are equal. A plus B is 180, so sine A will also be equal to sine B, right? Because sine theta is same as sine 180 minus theta in sine trigonometry. So A, if the B is adjacent angle, it will be 180 minus A, because A plus B is 180, so B is 180 minus A, right? So sine of B is also sine of 180 minus A is sine of A. So anyway, that's going to be same. So it doesn't matter, product of two sides and the angle between them. So even if I take any one of the four angles, I still get the same answer. That's the area of a parallelogram. Perimeter is sum of all sides. It doesn't matter what the shape is, it's going to always stay the same, sum of all the exterior sides. So I need to add A plus B plus A plus B. We'll get 2 into A plus B. When it comes to the diagonal, there will be two diagonals. One of them is AC, which is this. Other is BD. And the diagonals of parallelogram are not equal in length, are not necessarily equal in length. Some of the parallelograms might have, some of them might not, so not necessarily equal. So how do I find AC? You see this AC? This is found using a right angle triangle. Like if you see A, C, and then let me call this to be E. So let me use slightly different color, 1 second. Right, A, C, E is a right angle triangle. This is height h. If I take this to be x, so entire AE will be A plus x, and the diagonal is what I need to find. Right, so the diagonal, I'll use a right angle triangle, the Pythagoras theorem. So that will turn out to be the diagonal square equals to h square plus A plus x square. Right, so according to given dimensions, I will do. When it comes to this, right, there is one more diagonal which I can find, which will translate to, this is DF and this is FB, and then this is the diagonal that I need to find. And again, this is 90 degrees. So h square plus whatever this be, if I take y, this will be A minus y. So again, a right angle triangle, I apply and get the diagonal. As I said, that's why the two diagonals will be different in length, right? But you use the Pythagoras theorem to find the diagonal lengths. Two diagonals are different in length. That's one point to remember. The other point to remember is that the diagonals bisect each other. That is, this is where they're intersecting. So this half of diagonal is equal to this half, and that's basically half of the entire diagonal. Similarly, this part is same as this part, and these two are half of the entire BD. That's what the bisect basically means. Right? Those are the properties that you need to remember. So the first question, find the following for the given parallelogram. So area of a parallelogram. So they've given us 12 centimeters as one of the side. We don't know the other side. We need to find the area of parallelogram. Right, so as we also don't know the angles or anything, but here we have simple clue given, right? AB is 12, that's base. Height to that base is also given to us, right? From the C, they have drawn a height to the base AB, that is 4 centimeters, right? So that is basically 12 into 4, that is 48 centimeters is the area. What about the perimeter? Perimeter is basically sum of all four sides. I know 12 and 12, I don't know this, right? If I know x, I can obviously add all of that. See, x could be found out by this triangle. This is a right angle triangle, this is 90 degrees. 3 square plus 4 square should be equal to x square, right? because hypotenuse is x, so 3 square plus 4 square. So x square is 25, so x is 5. So this has to be 5 and this has to be 5. So perimeter is 12 plus 5 into 2, L, right? 2 into a plus b. So 17 2s are 34 centimeters is the centimeter square, and this is the perimeter. What about the length of the diagonal AC? So length of the diagonal AC is this, right? As I said, I'll try to find a right angle triangle. AC is this, so obviously I'll do, this is the another leg, and this is the height, and this is the 90 degrees. So I have a right angle triangle like this. CAE, this is 90 degrees, CE is 4, this is 12 up to B, and 3 centimeters is the length between B and E, so this should be 12 plus 3, 15. I need to find the AC. So AC square is equals to 15 square plus 4 square. 15 square is 225 plus 4 square is 16, that is 241. AC square. So diagonal AC is square root of 241. You cannot further simplify it, I guess, so that's okay. The point is, that's how you can find the diagonal length, right? I cannot find BD based on the given information in this question, okay? This thing, even if I draw it, I can find the height is 4 automatically, this is 4, but I don't know what is this length, right? If I take this as F, what is FB? I don't know, because I don't know what is this length. So from the given information, I can only find AC. That's what we have solved.